Now we're going to do some probability problems where things get a little more complicated. With the coin flip, since everything is just 1/2, things seem to be a little bit easier. But now we have a sock full of randomly colored socks, or a drawer full of randomly colored socks. Not sure why we have so many randomly colored socks, unless you're my son. He likes to have to mismatch his pairs of socks and then lose some. So I'm sure if we went into his room, we would find this situation or something very similar. So it says that you have 2 red, 1 blue, and 3 green socks in a drawer. Suppose you reach into the drawer without looking and choose a sock, replace it, and then choose another sock. You choose a total of 2 socks. Use this information to answer each question. Does the action choosing the first sock affect the outcome of choosing a second sock? So since we are replacing it, so replacing it is the key here. We're putting it back. So that means that these are independent events. So choosing the first sock does not affect it. So no, not affected. How can we use the counting principle to determine the total number of possible outcomes? So let's think about this for a minute. The total number of possible outcomes. How many possible outcomes do I have for my first choice? Well, I have 2 plus 1 plus 3. So 2 plus 1 is 3 and 3 plus 3 is 6. So I have 6 possible outcomes for my first choice of sock. Then for my second choice of sock, since I put the first sock back in, I still have 6 possible choices. So I'm going to multiply those together and I get 36. So there's 36 possible outcomes that I can get in this situation. Now we want to know the probability of choosing. First a blue sock and then a red sock. So what's the probability of getting a blue sock? Well, we have 6 total socks in there and we only have 1 blue sock. So that would be 1 out of 6. And since we're doing compound probability, and means multiply. We have 2 red socks, so we have 2 out of 6, and now we just multiply. So 1 times 2 is 2, 6 times 6 is 36. We can reduce that down to 1 out of 18. What's the probability we get a red sock and then a sock that is not blue? So we have 2 red socks out of 6. And then we want to know the probability of not getting a blue sock. Well, we only have 1 of them that's a blue sock. So that means that there's 5 left that are not blue socks. So we have 5 out of 6. I'm going to multiply across there and I get 10 out of 36. This is reducible as well. 10 divided by 2, that would be 5, and 36 divided by 2 would be 18. Once we get to 5 over 18, I don't think we can reduce any further. Let me show you how to do this in your calculator though, a little shortcut trick. So we can just do 2 over 6 times 5 over 6. Again, if you have one of the newer calculators, feel free to hit alpha, y equals, and then enter. Mine's a little older, so we have to do it this way. And then if we hit math, enter, enter, it puts it in fraction form. So we get 5 out of 18. This will always put it in the most reduced fraction form. So you don't have to do the math yourself. If we get to this point and we want to see if it's reduced, we can just do 10 out of 36 in the calculator, hit enter, hit math, enter, enter. And the calculator actually will reduce fractions for me, which is a nice little feature that I love. Excuse me. The next one says 2 socks with the first sock being green. Well, the first sock, we have 3 out of 6 socks, right, on our first straw. It doesn't tell me what color I want on the second socks. So it's just going to be 6 out of 6, right? Well, that's the same as 1. So I don't even actually have to put that on there. So my answer would be 3 out of 6, which will reduce down to 1/2. Now, let's see here. Suppose you reach into the drawer without looking, choose a sock, do not replace it. Okay, so we are not replacing it. And then choose another sock. You choose the total of 2 socks. Remember, there are 2 red, 1 blue, and 3 green socks in a drawer. Use this information to answer the questions. Does the action choosing the first sock affect the outcomes of choosing a second sock? If so, how? Explain your reasoning. Well, yes, it absolutely does. We have fewer choices. On the second draw. That's going to affect my probability on choosing the second sock. How can you use the counting principle to determine the total number of possible outcomes? So on our first draw, we have 6 possible outcomes. On our second draw, we will only have 5 possible outcomes. If I multiply that together, then I get 30. So there are 30 total possible outcomes when drawing the 2 socks from the drawer. So now we're going to calculate the probability. What is the probability of choosing a blue sock? First, so remember there's 1 blue sock and we have 6 total socks in the drawer. Now on my second draw, I took a sock out. I took a blue sock out. And so now I am left with 5 socks. I still have 2 red socks in there. So now I'm going to multiply across and I get 2 over 30. We can reduce that down to 1 out of 15. On our next, the next set, a red sock and then a sock that is not blue. So remember our first draw of socks, we have 2 socks, or we have 2 red possible socks and we have 6 total. On our second draw, we took one of those red socks out. And so now we're down to 5 total socks. 1 of the 5 is blue. So now we only have 4 socks in there that are not blue. We multiply across. 2 times 4 is 8. 6 times 5 is 30. And I can reduce this down to 4 out of 15. So now on this one, it says 2 socks with the first sock being green. So again, I've got 3 out of 6 on the first draw. Now I have 5 socks left and it doesn't really tell me what color I want the second sock to be. So again, it's 5 out of 5. So it's still just 1, which leaves me with 3 out of 6, which reduces down to 1/2.